So we've seen this sequence before. We've seen this sequence before. In this video, we're going to show that this sequence is bounded from above and is bounded from below. So we're going to treat this as one part. So first we're going to treat it as one part, and then later on we're going to treat this as another part. So first let's show that this sequence is always bigger or equal to 1. So to do that, let's start out with 1 over n is always bigger or equal to 0. Well, if you look at the 1 over x graph, it will look something like this. Remember, we are working with sequences, so n can only be integers. N can only be positive integers. So it makes no sense to have n as being 0.372 or whatever. It can only be positive integers. So if you look, you have to agree. So we are trying to show this. We are trying to show that this sequence will always be bigger or equal to 1. Later on, we will look at this later on. But let's just look at this part first. So to show this, start out with 1 over n being greater or equal to 0, which it is, because anywhere on the positive side, you can see that 1 over n will always be above 0. We know that will be strictly greater than 0, but let's just say it's bigger or equal to. So to show this bit here, start out with this 1 over n being greater or equal to 0, and then add 1 equally to both sides. So you add 1 here. Sorry. So you add 1 here. You add 1 here. So that's 1 plus this thing, and then add 1 over on this side. That will then give you this. So there, we've just shown that. We've shown that the sequence itself is bigger or equal to 1. So basically, you start out with this statement here, and then you add 1 equally to both sides. So this will be true. Now we will need to look at this part here. So to show the second part, start out. We will now show this part here. So to show the second part, we will start out by saying, well, 1 over n. Let's say 1 over x here. The 1 over n will always be less than or equal to 1, because okay, when it's 1, it's dead on 1. When it's 2, when it's 2, it's going to be a half, and when it's 3, it's going to be a third. You can see that it's always less than 1 over n will always be less than 1, because remember, when it comes to sequences, you start with 1 and then you go all the way to infinity. So you can't really start anywhere below 1 when it comes to sequences. So n cannot be anywhere below 1. So if the smallest value for n is 1, then this statement must be true. This statement must be this inequality here must be true. So to show this, start out as 1 over n being less than or equal to 1. And then add 1 equally to both sides. So that will give you this, which is saying that the sequence itself is always less than or equal to 2, which is this bit here. Now that's correct. So therefore, this sequence is always trapped between 2 and 1. Okay.